Hello everybody, second Hyperstuffies here. What is a Cartesian grid and how do you plot coordinates on a Cartesian grid? In this video I'll explain how to do both. Now a Cartesian grid looks like this. I'm pretty sure you've seen one of these before. A Cartesian grid is made up of 4 quadrants. Quadrant 1, 2, 3, and 4. And there's one other major part of a Cartesian grid we need to know. The center, where both lines overlap, I'm just going to put a dot, is called the origin. And later on, you'll understand what this is. But this represents 0, 0. Now on a Cartesian grid, there's 2 lines. The horizontal line is called the x-axis. And I'm pretty sure you've heard this before. The vertical axis is called the y-axis. Now, in math, it's not that simple. In this case, there's a positive and negative side to both axes. On the x-axis, the right side, and there's a left side. The right side is always positive. So, for example, positive x. But the left side is negative x. So, the left side is always going to be negative x, while the right side is positive x. Now, the idea is kind of the same for the y-axis. Y-axis would look like this, not on a Cartesian grid. Up on the top would represent positive y, while on the bottom, negative y. So, up and down, up will always be positive y, while the bottom is negative y. Now that we know the basics of a Cartesian grid, let's get on to what a coordinate is. A coordinate looks like this. The first number will always be part of the x-axis, while the second will be the y. An example of this could be 3, 2, -1, 4, and the list could really go on. Now you may be wondering, why does x go first? Why can't y go first? Well, it's kind of a universal rule for mathematicians. X always has to go first. So the first one's right. Second one is wrong. An easier way to understand this is in the alphabet, x always comes first. Hence, x being first on a coordinate, and y comes second. Explaining why it's second. Now you may be wondering why there is brackets and a comma. It's pretty simple. If you had a long list of coordinates, for example, 3, 4, -2, 1, 1, -2, etc., this would be really confusing to look at. You would think it's just 34, -21, and whatever that is. You have to separate them. So every time you kind of show a coordinate, you have to put it in brackets, like this, and separate the two numbers with 1 comma. Therefore, you know it's 3, 4, and that's one coordinate pair. Any number in a bracket is called a coordinate pair. And the numbers itself are kind of called a coordinate. Now, when you look at a coordinate, like I said before, it's x and y. You may be wondering, why is it not -x and -y? Well, technically it is, but x and y is the easier way to explain. With numbers, there can be negative numbers and positive numbers. I'm pretty sure you've seen the number line before. Number line has a 0 And anything on the right side is positive. Well, anything on the left side is negative. This is kind of the same, like I said before, with the x-axis. And on a number line, there are increments. For example, 1, 2, 3, 4. And -1, -2, -3, -4. This is pretty much the same with plotting coordinates on a Cartesian grid. Now I'll get to that now. With graph paper, this would be a lot easier, but since I don't have graph paper right now, I'll be using this whiteboard. Now these are all increments of 1. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, so on and so forth. Now remember, this is the positive x-axis. This is a negative y-axis. This is a negative x-axis. Oops, that's a negative x-axis. And this is the positive y-axis. Now, like I said before, a coordinate pair, xo is always first. So let's actually learn how to graph now. I'm just going to pick 2 random numbers, 3 and 2. So this is kind of like a number line. X is first, and this is a positive number. You could put a positive if you really wanted to. I'll do that so it's easier to understand. Positive 3 pretty much means go in the positive x direction 3 times. 1, 2, 3. Right? And because we know it's a positive 2 and it's in the y-axis, we go to the positive y-axis. So 1, 2. So the plot or the point would go right here. Now I'm pretty sure you might be a little bit confused onto why, and I'll explain that. Pretty much, in simpler terms, we went in the x-axis because this is positive 3 times, 1, 2, 3, and because this is 2 and it's in the y-axis and it's a positive number, went to the positive y-axis, 1, 2. So 1, 2, 3, 1, 2. Let's do another example, but this time a little harder. What about -1 and -4? Now, as you could see, they're both negative numbers, so we need to go in the negative direction. And since we know the first number is the x-axis, we go -1 here. So -1. And the negative y-axis is down, so we go down for spaces. So 1, and then 1, 2, 3, 4. The point would go right here. And, like I said before, this pretty much represents 1, -1, and then -4. So I'm pretty sure you use the number line. This pretty much means going 1, and then 1, 2, 3, 4. You could use these bumps if you really wanted to, but I say it's easier to not. Now let's do 2 more examples. What about -1, +3? It's simple because, hold on, you go in the negative x-axis 1 time, but you go up 3. 1, 2, 3. Therefore, the point would be right there. Now let's do another example. What about +2, -5? We know it's a positive x, so we go in this direction to the right 2 times. 1, 2. But we go -5 or down 5. 1, 2, 3, 4, 5. Therefore, the point would be right here. Now, I'm pretty sure you're wondering Why do we even need to use these Cartesian grids? Well, in the next video, I'll explain one type of graph. In graphing, there are many different equations that could be represented. For example, sometimes it could be going up. Sometimes it could be going up, could grow, go like this. There are many different types of graphs. There are many different types of graphs, and I encourage you to look at each different one. Next video, I'll be explaining this graph. It's called a linear graph. Anyway, hope you enjoyed this video, and if it helped, if you want, you could leave a thumbs up and maybe subscribe. Anyway, guys, goodbye. See ya.